Okay, in this video, I want to talk about how we can solve physics types problems when in our discussion of mixture problems. So in this problem, we have two people and they start a 9-mile race at the same time. If Carino ran the race 6 miles per hour and finished the race 30 minutes before Ria, how fast did Ria run? Okay, so I'm going to break it up as the two different people. Looks like they have an O at their name. And then we have Ria here, and that should be capital R. Okay. Now, with these types of problems, you have to know the equation distance equals rate times time. Okay, you're going to need to know that to do that. I would argue you already know if you drive 30 miles per hour. So if you drive 30 miles per hour, well, that translates to 30 miles per hour. And so this is your distance and this is your time, right? So you have that rate equals distance over time. That's just a different version of that equation, all right? Okay, so let's get back to the problem at hand, but we do need to use that equation to be able to solve this problem. All right, so what do we know about Carino's rate? What do we know about their time? And what do we know about their distance? Let's try to break it up. So Carino's ran a race at 6 miles per hour, and so that would be their rate. They finished the race 30 minutes before Ria, and we know that this is a 9-mile race, so I know that this is 9 right there. Now, I can actually solve for the time perfectly right now because I know distance and rate. So distance and rate, I know these, so that means that 9 equals 6 times t, and so t must equal 9/6 or 3/2 or 1.5. So an hour and a half. So I'll put 1.5 there. Okay. Now, what do I know about Ria and this race? Let's find out. So I know that Ria finished 30 minutes after Carino. I know that that must be true. I also know that this is a 9-mile race. Okay, so 1.5 hours plus 30 minutes, which is 0.5, is coming at 2 hours. Okay, so now I can find that rate because I know that the distance equals 9. I know that the time equals 2, and I could find that rate by dividing by 2. So that means that rate equals 9 divided by 2, or 4.5. Okay, so 4.5 miles per hour would be how fast Ria ran. So that's one way that you can solve that problem. I think it's helpful to kind of break things up into pieces and write what you know and write what you don't know. Okay, let's look at this next question. Freight train leaves a station and travels due east at 30 miles per hour. 2 hours later, a passenger train leaves the same station and travels due east on a parallel track at the speed of 90 miles per hour. How long will it take the passenger train to overtake the freight train? So this is kind of a classic algebra question, and there's a lot to unpack, but the first thing I'm going to do is I'm going to write freight, and I'm going to write everything I know about that train, and passenger, and then everything I know about that train. Okay, again, this is a distance, rate, time type of problem, so I need to know that equation. And what is the rate, time, and distance of this train? I can find that. Now I'm going to use rate and just a little apostrophe there just so I can keep track that these might be different. So it's just a little method that I use. I'm going to call it R prime, T prime, distance prime, just to kind of keep track of, this one is different than this one, but we can use the same letters. Anyway, okay, so for the freight train, it's traveling at 30 miles per hour, so I'm going to write 30. What else do we know? Do we know about the time? I do know about the time. I know that this freight train has been traveling 2 hours before the passenger train has even started. So because of that, I'm going to write t prime plus 2, and then t prime will just equal itself. You can switch these around and go t minus 2 if that's how you like it, but this will work. So for the freight train, what else do I know? Do I know anything about the distance? No, it doesn't look like I actually know anything about the distance. So I'm going to put a question mark unless I figure it out later. What about the passenger train? Do I know how fast the passenger train travels? Yeah, it looks like it travels 90 miles per hour. I know its time in relationship to the other. So here I'm just going to write t prime equals t prime. And for the distance, it doesn't look like it's given to me. Okay. Now, it has something to do with the passenger train overtakes the freight train. So I have a feeling that we want to find out when would they be equal to each other. When is the distance of the freight train equal to the distance of the passenger train? And that would be where it overtook, right? So let's find that. So again, distance equals rate times time. So I can rewrite this as 30 t prime plus 2. And that would be equivalent to 90 t prime. If you want, you can now drop the primes, but I'm just going to keep going. So 30 t prime plus 60 equals 90 t prime. Okay, well, I can subtract on both sides. So 60 equals 60 t prime. And I can divide both sides by 60. It looks like t prime equals 1. So it's 1 hour in the passenger's clock. They've been traveling for 1 hour. So you can write 1 there. From the freight train, it's 3 hours. Okay, so it's a relativity problem. It's who you're determining. How long will it take for the passenger train to overtake the freight train? I'm going to write 1 hour. So I'm going to write 1 hour as my final answer. So 1 hour there. But it depends on who's asking the question. But for this, the way it's written, I'm going to write 1 hour. All right. Little short on time, but let's see what we can do for the next problem. 2 cyclists start at the same point and travel in opposite directions. One travels 3 miles per hour slower than the other. In 6 hours, they travel 234 miles apart. Find how fast each cyclist is traveling. So I'm going to break this up as a fast cyclist and a slow cyclist, and I think that should be easy enough for me to determine. So again, I'm going to use r prime, t prime, d prime there, and I should be able to determine it from there. So let's see what's going on with the fast cyclist. One travelers is 3 miles per hour slower. So I'm just going to say r prime plus 3. Again, you can write it the other way, and you can write it with r minus 3 if that's the way you like it. They're both traveling for 6 hours, so I know that the time is equivalent. It's both 6. And then in this problem, they're 234 miles apart after they've been going in opposite directions. So I don't know how much they've individually have traveled, but I can determine it totally. I can say that the distance of the fast person plus the distance of the slow person is 234 miles, and I can solve it that way. So again, we need to know distance equals rate times time. That's assumed that we know that. 6 times r prime plus 3 equals 6r prime, and then we can begin to solve. 6r prime plus 18 equals 6r prime, and something went wrong. What went wrong? Okay, I made a little mistake there. For some reason, before I had them set equal to each other, and we need to add them. So I have 6 times r prime plus 3 plus 6r prime equals 234. And then we can find 12r prime plus 18 equals 234. And from there, we can find that 216 divided by 12 equals r prime